Welcome back to Science to Sleep By. Tonight we are exploring one of the humanity's most fascinating dreams, the colonization of Mars. For decades, science fiction has painted vivid pictures of thriving Martian cities beneath glass domes, families watching sunset over red deserts, and spacecraft regularly traveling between Earth and our neighboring world. In recent years, that dream has seemed closer than ever. Private companies, national space agencies, and some of the world's brightest scientists are actively developing technologies that could eventually carry humans to Mars. Yet, despite all this progress, humanity remains firmly planted on Earth. The question is not whether we can send people to Mars, we already possess much of that capability. The real question is why establishing a permanent, self sustaining colony remains so difficult. Tonight, as we slowly journey through the science, engineering, and realities of deep space exploration, we'll discover what is actually preventing us from colonizing Mars, according to scientists studying the problem today. When most people think about Mars, they imagine it as Earth's next door neighbor. In cosmic terms, that is true. Mars is one of the closest planets to us, but the word close can be misleading. Even at its nearest approach, Mars remains tens of millions of miles away, depending on where planets are in their orbits. A trip to Mars can take anywhere from 6 to 9 months using current spacecraft technology. Scientists often describe this as the first great barrier to colonization because every challenge becomes magnified by distance. If an astronaut breaks a bone aboard the International Space Station, help from Earth can arrive relatively quickly. If a critical system fails on Mars, assistance could be months away. Communication is also dramatically slower. Radio signals travel at the speed of light, but even light requires several minutes to cross the gap between the Earth and Mars. During certain periods, a message can take more than 20 minutes to arrive. That means real time conversations become impossible. Mission control can't simply guide astronauts through emergencies as they occur. Martian settlers would need to solve many problems entirely on their own. Scientists often compare Mars missions not to Antarctic expeditions but to early ocean voyages, except with no possibility of rescue. The vast distance also makes transportation incredibly expensive. Every pound of equipment, food, fuel, medicine, and construction material must survive launch from Earth and endure a journey through deep space. Even with advanced reusable rockets, the economics remain staggering. Until transportation becomes dramatically cheaper and more reliable, the simple reality of distance will continue to stand between humanity and permanent Martian civilization. Perhaps the greatest obstacle identified by many researchers is not distance itself, but what happens during the long journey. Beyond Earth's protective magnetic field lies an environment filled with dangerous radiation. On Earth, we rarely think about this invisible shield surrounding our planet. The magnetic field deflects many charged particles streaming from the sun, while the atmosphere absorbs additional radiation from deep space. Astronauts traveling to Mars would lose much of that protection. During the months long voyage, they would be exposed to galactic cosmic rays and solar energetic particles capable of damaging cells, increasing cancer risks, harming the nervous system, and potentially affecting cognitive performance. Scientists still don't fully understand the long term biological consequences of such exposure. Mars itself offers only limited protection. The planet possesses a thin atmosphere and lacks a global magnetic field comparable to Earth's. Measurement from NASA missions suggest that astronauts living on Martian surface would continue receiving significantly higher radiation doses than people on Earth. Researchers have proposed numerous solutions. Underground habitats could use Martian soil as shielding. Water storage systems might be incorporated into habitat walls. Some engineers have imagined artificial magnetic fields surrounding future settlements. Yet, every solution introduces additional complexity, cost, and engineering challenges. Radiation remains particularly troubling because it is not merely an inconvenience, it directly threatens human health. A colony can't thrive if its residents face elevated risks of cancer, neurological disorders, and reproductive complications. Before Mars can become a permanent home, scientists must develop reliable methods of protecting human beings from an environment fundamentally different from the one in which our species evolved. Even if distance and radiation were solved tomorrow, another enormous challenge would remain. Humans are remarkably dependent on Earth. Every breath we take, every sip of water we drink, and every meal we consume depends on planetary life support system that has been operating for billions of years. Mars offers none of these comforts naturally. Its atmosphere consists primarily of carbon dioxide with almost no breathable oxygen. Surface temperatures often plunge far beyond freezing. Liquid water is scarce and unstable at the surface. The pressure is so low that unprotected human exposure would be fatal. Scientists therefore view colonization as less a transportation problem and more a life sports problem. A successful settlement would need system capable of producing oxygen, recycling water, growing food, managing waste, generating power, and repairing equipment with minimal support from Earth. Current technology can perform many of these tasks on a small scale. The International Space Station recycles a significant portion of its water and air. Experimental greenhouses have demonstrated food production in controlled environments. However, scaling these systems for hundreds or thousands of settlers is vastly more complicated. Every machine eventually breaks, every supply chain experiences disruptions. A true colony can't depend indefinitely on shipments from Earth. It must become increasingly self sufficient. Scientists often emphasize that creating a sustainable Martian settlement means effectively building a miniature Earth ecosystem inside an artificial habitat. That challenge involves biology, chemistry, engineering, agriculture, medicine, physiology all working together. Until humanity learns how to create stable, long term life support systems capable of operating for decades without constant resupply, Mars will remain more of an outpost than a genuine colony. One of the most overlooked challenges of colonizing Mars is gravity, or more accurately, the lack of it. Here on Earth, every human body has evolved under the constant pull of one gravitational force. Our bones, muscles, cardiovascular systems, and even the way our bodies distribute fluids depend upon this environment. Mars possesses only about 38% of Earth's gravity, and scientists still don't know exactly what living in such conditions for years or decades would do to human body. Evidence from astronauts abroad, the International Space Station provides some clues. Even with rigorous exercise programs, astronauts experience muscle loss, reduction in bone density, changes in eyesight, and alterations to their cardiovascular systems after spending extended periods in microgravity. Although Mars has more gravity than the space station, it is still significantly weaker than Earth's. Researchers worry that children born and raised on Mars might develop differently from children on Earth. Their bones could grow weaker, their muscles could develop differently, and their bodies might adapt so completely to Martian gravity that returning to Earth would become difficult or even impossible. Scientists are also studying how low gravity could affect pregnancy, childbirth, and human development across multiple generations. The truth is that nobody knows because no human has ever lived in such an environment for that length of time. Some experts suggest that future Martian habitats may need rotating sections that create artificial gravity through centrifugal force. Others believe advanced medical treatments and specialized exercise programs could help settlers maintain their health. Yet, every proposed solution introduces additional complexity and engineering challenges. Colonizing Mars is not simply about transporting people to another planet, it is about ensuring that humans can remain healthy there for years, decades, and eventually generations. The gravity issue reminds scientists that Earth is more than just a place where life exists. It is an environment that has shaped every aspect of our biology over millions of years. Leaving Earth means leaving behind one of the most fundamental conditions that help make us human in the first place. Until researchers fully understand how low gravity affects long term health, Mars colonization will continue to involve significant biological risks that can't be ignored. While science and engineering often dominate discussions about Mars, many researchers argue that the greatest obstacle may ultimately be economic rather than technological. Building a permanent settlement on other planets would require resources on a scale unlike anything humanity has ever attempted. Every spacecraft, habitat module, power system, medical facility, greenhouse, communication network, and industrial machine would need to be designed, tested, manufactured, launched, and maintained at enormous cost. Even today, sending a relatively small robotic rover to Mars can cost billions of dollars. Establishing a self sustaining colony capable of supporting hundreds or thousands of people would require investments measured not merely in billions but potentially in hundreds of billions or even trillions of dollars over many decades. Scientists and economists often ask a simple question: who pray for Mars? Government face competing priorities such as healthcare, education, infrastructure, and national security. Private companies seek financial returns on their investments, yet Mars currently offers no clear economic product that would justify such extraordinary spending. Unlike historical colonies on Earth, Mars possesses no easily accessible resources that can be transported back profitably to our planet with current technology. This creates a unique challenge. A Martian colony would initially consume far more resources than it could produce. Supporters of colonization argue that technological innovation, scientific discoveries, and long term survival of humanity justify the investment. Some researchers believe future industries such as space manufacturing, asteroid mining, or advanced energy production could eventually create an economic foundation for interplanetary civilization. Others caution that such possibilities remain speculative. What is clear is that Mars colonization is not a project that can be completed by a single company, government, or generation. It would likely require decades of international cooperation, constant funding, and public support, unlike anything seen in modern history. Scientists frequently emphasize that the challenge is not whether humanity can reach Mars, but whether humanity is willing to commit the vast resources necessary to stay there permanently. In many ways, the economics of Mars may prove to be just as demanding as the science itself. Perhaps the most human challenge of all is one that can't be solved with rockets, habitats, or advanced technology. It is the challenge of mind. Scientists who study long duration space missions often emphasize that Mars colonization is not only an engineering problem but also an physiological one. Imagine living on a planet where stepping outside without a protective suit could be fatal, where every window reveals a barren red landscape stretching endlessly toward the horizon, and where Earth appears in the sky as nothing more than a distant point of light. Future Martian settler would experience a level of isolation that no human community has ever faced. Even the most remote research stations in Antarctica can receive emergency assistance within days. A Mars colony would be separated from Earth by millions of miles and months of travel. Communication delays of several minutes each way would make conversations with family and friends feel slow and unnatural. In moments of crisis, homesickness or grief, colonists could not simply return home. Researchers who have studied isolated environments, including submarines, polar stations, and simulated Mars habitats, have found that confinement, limited social interaction, and separation from familiar surroundings can create stress, anxiety, depression, and interpersonal conflict. Small disagreements between crew members may become magnified when there is no possibility of leaving the environment. Scientists also wonder how future generations born on Mars might view Earth. Would they feel connected to a world they had never seen, or would they develop a distant Martian identity? Maintaining mental health in such circumstances would require careful habitat design, recreational opportunities, private living spaces, virtual connections to Earth, and strong social support system. Some experts even suggested that future colonies may include parks, artificial natural environments, and immersive digital experiences designed to reduce feelings of isolation. The challenge highlights an important reality about colonization. Human beings are social creatures deeply connected to communities, cultures, and natural environments. We are accustomed to blue skies, flowing water, changing seasons, and the presence of billions of other people. Mars offers none of these things naturally. A successful colony would therefore need to provide not only food, air, and shelter but also meaningful quality of life. Scientists increasingly recognize that survival alone is not enough. For a Martian civilization to endure, people must be able to thrive emotionally and psychologically as well as physically. In the end, one of the greatest questions surrounding Mars may not be whether humans can live there, but whether humans can truly feel at home there. As we reach the end of tonight's journey, it becomes clear that the dream of colonizing Mars is not being held back by a lack of ambition. Humanity already possesses the imagination, the motivation, and much of technology needed to bring being exploring the red planet. What stands in the way are immense scientific realities of distance radiation, life support, and long term sustainability. Mars is not simply another destination, it is an entirely different world, one that challenges nearly every biological and technological system upon which human life depends. Yet, history shows that humanity has repeatedly overcome obstacles once considered impossible. The scientists studying these problems don't ask whether solutions exist. Instead, they ask how long it will take to develop them. Perhaps someday, generation from now, Martian cities will stand beneath the red skies. For now, however, the greatest barrier to colonizing Mars is not a single problem, but the combined weight of many extraordinary challenges. Thank you for joining Science to Sleep By. Rest well, and until next time, keep wondering about the universe above us. Good night.